So, the three biggest things in 7.1 is going to be, well, let me just say this. In 7.1 and 7.2 material, you're going to have to be drawing a lot of these right here, the uniform distribution and the normal distribution. And I'll tell you what you ought to do there to save yourself a lot of drawing time, because you're probably going to do 5 or 6 of the uniform distribution, and you're probably going to do about 20, 25 of the normal distribution. Because 7.1 and 7.2 is all based on graphic representation of the normal distribution. So you're going to be drawing that curve over and over and over again. So I tell you how to avoid having to draw it over and over and over again. Now this is a little picture of the empirical rule. Remember the empirical rule, 34, 34, 13.5, 13.5. You kind of have to remember that when you're working with the normal distribution. You kind of keep that in the back of your mind and say, okay, this is 50%. So, you know, you have to think about that while you're drawing your normal distribution. And in 7.2, we're going to be using the graphical approach for normal distribution to find the probability using the z-score formula, which you already know that. X minus the average over the standard deviation. And the X formula, which I call it Oz plus mu. I turn this around, and that's the standard deviation times the z-score plus the average. I'll finish writing that down. And hopefully you've got all that written down. And we'll move on to the third part of 7.2, and this is called the z-table. Now you don't have to write this down because it'd be ridiculous to write it down, but you need to look for it in your book. It's usually in your book. Nope, that's not it. Where'd it go? Well, there it is. I want you to look at it. It's called the standard normal distribution t-table. It's called the z-table. Now, you need to find that in your book, or you need to, when you go home tonight, you need to pull it up on the Google. Just call it z-table, and you'll find some pictures of it, and you can print it out. Those of you that bought a book, it should be in your book. Now I'm going to show you how to use the z-table as well as your calculator. Like I always do, I'm going to show you how to use both. Okay? So you don't have to copy that down, but there's 2 pages of it. There's the left-hand side, which is the negative z-table. All your z's are negative. And then the right-hand side, all your z's are what? Positive. And that goes along with the normal distribution right here. Z-scores are negative, z-scores are positive. Okay, so now we're going to go ahead and get used to the uniform distribution. The uniform distribution is pretty simple because it only deals with one thing. And what is the only thing that is uniform in our universe? What is the only thing that we cannot manipulate? We can't change, huh? Time. It's the only thing that we can't change. Therefore, it's uniform. There's no variance in it whatsoever. It's going to continue going the same rate that it's been going for the last 2 billion years. All right? It's not going to change. So that's why you have uniform distribution. Now, under the curve, and you need to write this down, and I'm going to put it in a text box here. And I've already said this. Under the uniform and normal distribution curves, I'm going to put this in quotation marks, area slash percentage slash probability is always equal to what number? 1. 1.0000. Now I put 4 digits for a reason. 4 decimal places is usually equal to the area slash probability slash percentage. 2 decimal places is usually equal to a z-score. And from here on out, anytime I draw a area, I'm going to use 4 decimal places, whether it's 1.0000 or if it's 0.3456. When you see 4 decimal places, that automatically should click in your brain. This is an area slash percentage slash probability. Because area, percentage, and probability is all the same thing in this chapter. If the question asks for a percentage, that's the area, that's the probability. If it asks for probability, that's the percentage or the area. If it asks for an area, that's the percentage or the probability. So whatever they ask for, you're looking for the same thing. Okay? Question on that. So, with that information, you can go to your handy-dandy text maker and you can put the area under this uniform curve is 1.000. Now, usually, with a question like this, let's see if I copied one. I think I did. Here's one that says time. Okay? Here's a time question. This is the type of question you're going to see on a test or homework. The graph to the right is the probability, this graph right here, uniform probability, for a friend who is X minutes late. Well, I'm going to put a line through here, and I'm going to take X out, and I'm going to say usually 0 to 30 minutes late. Well, let's say 0 to 30 minutes late. Okay, so I'm going to put that in there for that, for X. Make that change. So that means that this point right here is what? 0. And this point right here is what? 30. Now, using your mathematics that you learned back in pre-algebra, tell me what the height of that box is. You've got the area, you've got the length, so tell me what the height is. Everybody should be working, not just staring there going. Okay. Area is equal to what? Area of a quadrangle is equal to what? Length times what? Height, or base times height, whatever you want to call it. Length times width, or base times height. We'll call it base times height since I asked you for the height. Now, what do we have? Tell me what we have in the original problem. I'm not even looking at A and B. I'm just looking at the graph to the right is the uniform probability distance of a function of a friend who is 0 to 30 minutes late. In other words, if you was to go to Outback right now and tell your friend to meet you at 1 o'clock, you know they're going to be there between 1 o'clock and what? 1:30. And you know you've got friends like that. I'm one of those people. Usually mine is about 15 minutes. I'm usually 15 minutes late, 0 to 15 minutes late. So, what is my area? 1.000, yes. 1.000, 4 digits. In this chapter, chapter 7, you need to get used to area, percentage, and probability being the same number. Whenever somebody asks you for the area in chapter 7, you should look for 4 decimal place number. Is equal to, what's my base? 30 times h. Now, how do you solve for h? Divide by 30, Hubert. Thank you, whole class. Glad all of you remembered that. So our height is 1 over 30. So this height right here is 1 over 30. So does everybody understand that the height of this box is 1 over 30? Everybody understand that? Yes. Okay. Now do A. Find the probability that your friend will be between 25 and 30 minutes late. So I'm going to take my handy dandy line maker and I'm going to use magenta and I'm going to draw a line here. Now I'm going to draw a magenta square, rectangle. And I'm going to say I want to know what that area is right there. Why? Because that's between what? 25 and 30 minutes. So again, your pre-algebra days, area is equal to length times, or base times height. Very easy pre-algebra formula. And I can tell you right now, on the test, you're going to have 2 or 3 of these questions. And they're all going to have to do with time. So A is going to equal area is equal to base, which is my base. What's my base here? 5, Hubert. That's right, class. Thank you for enunciating and being loud enough to where I didn't have to hear woo. And what's the height? 1 over 30. And no, you do not need a calculator for this because 5 times 1 is what? And 5 over 30 is what? Huh? 1/6. And everybody in here should know that 1/6 is equal to 0.17. 0.1667. Why did I write it 4 decimal places? Because that's the area in this rectangle right here. So what kind of percent chance your friend is going to be 25 to 30 minutes late? A 17% chance. Okay? It is 10 a.m. There is a 50% probability the friend will arrive within what? Come on, people, use your common sense.
17 minutes?
What's half of 30 minutes?
15.
15. So what time will they show up?
15.
10:15. Okay? Because what's half of 1? 0.5000. And 0.5000 is going to fall at 15 minutes because you know that 50% is halfway between 0 and 30. That's one type question that you'll have. Let's do another one. I'll just make this one up. Let me pull in my handy dandy. Uniform curve. Now, what I tell students on the uniform, find you a uniform curve like this on Google. Copy it over to a word processor, put about 6 of them on one page, and run you about 5 or 6 copies. And then you won't have to draw this every single time. Now you think this is going to get old? It's going to get really old with the normal distribution where you're going to have 80% more because uniform you're only going to have 5 or 6 questions, where the normal distribution you're going to have 500 or 600. I'm just kidding. You're going to have more than 5 or 6 with uniform. Okay? You ever rub your hands and you find a bump that's not supposed to be there? I just found a bump. It feels like a bone. Oh, okay, yeah. It's there. I just never felt it before. There's on another one too. Okay. I'm weird. Alright. So here we go. I'm just going to say your math teacher usually lets class out the last 10 minutes of class time. What is the probability that he or she will let you out the last 3 minutes of class? There's your question. Your math teacher usually lets you out of class the last 10 minutes. So from 0 to 10 minutes is the last minutes of class. I just gave you a hint right there. 0 to 10 minutes. Now you should be able to do the rest. So 1 is equal to 10h. So what is my height? 110. I can't get anything past y'all. Y'all so smart. I just can't talk very loud. That's all. So now you take your handy dandy rectangle maker and you say, what is the probability that he or she will let you out the last 3 minutes of class? Well, the last 3 minutes of class will be a rectangle right here with a base of what? And, 7 to 10, what would it be? 3. And 3 times 1/10 is 3/10, and I'll do that. You don't have to use your calculator. 3 over 10 is 0.3. I guarantee you somebody punched it in a calculator.
I did.
Sad, but.
I did. I used my calculator.
You're kidding me.
I'm not.
No comment. So,
I feel good about it, so.
3 divided by 10 is equal to 0.3. Now, y'all think you got uniform distribution down good? I mean, that's all there is to it. Question, gripe, complaint. So what is the complement of 0.3? 0.7. So if I asked you, what is the probability that he will let you out between 11:50 and 11:57, you would tell me 70%. And that's how you do uniform distribution. Now let's talk about normal distribution, because this is where you're going to be spending most of your time in Chapter 7. Because you can't do Chapter 8 and 9 if you don't understand Chapter 7. First of all, get you one of these, and you need to use it. I mean, you need to make copies of it. I usually tell people to put 3 or 4 on a page, because you got to have some work to do area to do your work, and run you about 5 or 6 copies of these. Now, in some of your questions, the mean is going to be equal to 0, and the standard deviation, which is a sigma, lowercase sigma, is equal to 1. Okay? I'm trying to make a sigma out of this. Well, here we go. Anyway, mu is equal to 0, and standard deviation is equal to 1. And that's when it looks like this. Now, are they going to be mu, is mu always going to be equal to 0 and standard deviation equal to 1? No. The alternative to that would be mu is equal to 100 or 105 or 110 or 90 or 50 or 25 or any number. And the standard deviation, I'm going to make it easy, is equal to 25. Now, these are the 2 type problems you're going to see in Chapter 7, I think 7.2. But what do you do in 7.1 with this? Well, right now you just learned how to draw the graph. Well, I've been showing you how to draw the graph ever since the first time we did a normal distribution. So when you got to Chapter 7, you would know what to add on the right side and what to subtract on the left side. So, of course, if your mean is 0 and your standard deviation is 1, it will look like this. And you could apply your empirical rule. Now, what I mean imply, you need to apply, you need to mentally, and that's what this means. Think of this mentally. Think of this mentally overlaying this right here. Okay, mentally. When you're doing this right here, you're mentally thinking about this. Because half of this is what? 50%. So 50% is going to fall right here. So you know this side is 0.5000, and you know this side is what? 0.5000. But they may ask you for another percentage. What if they asked you 67%? Show 67%. Well, how do you do that? Well, it'll say percentile, and then it'll have a little 67 right here. Okay? So if you need to show that, you take your handy dandy straight line maker. And where is 50%? Right? 0. Well, what would 1 be? Well, think of this mentally. 650 plus 34 would be what?
84.
84. So you know 1 is 84%. That's too much. You see what I'm saying? Then what's half? Well, half of 13 is what? 34 is what? 17%, Hubert. Yeah, that's right. And 17 plus 50 is what? Wow. Then you know, I'm just going to put a little rectangle there because I forgot to change it. You know that 67% is about right there. Now, why do you need to know that? Well, when you get the answer after you use the z-table or you use the calculator, and your calculator z-table comes up with 32%, you know what? Something's wrong. Because you're supposed to be a z-score of 0.5 or somewhere right in there. In other words, the empirical rule gives you a common sense backup for your answer up here. If you don't know the empirical rule, then you just put out an answer and you have no idea if it's right or not. But if you know the empirical rule, you can use the empirical rule to add up the areas and say, okay, I think it's going to be around 67%, it's going to be around 0.5. And you can bounce that against the empirical rule. Okay? So you need to be able to graph this normal distribution. So that was 67, and you would put a line here, and then you'd shade this side over here because it's asking for the 67th percentile. All right, let's do another one. Of course, you have to draw it because everything in Chapter 7 is based on the graphical representation. So you're not going to get away from it unless you just want to get all of them wrong. I want you to draw me an area of 75%. Okay, get to it. 75%. So it would look like the 75th percentile. P and then a little 75. Bring in the empirical rule mentally. Okay, shut up. Got to go back over this now. All right, so P75. Well, we said that this was 84.
Right.
Well, that's not going to help us because 84 is not 75, so you're going to have to use interpolation. We said that this was 67.
Right.
Well, half of 7 is what? 3.5. So 67 plus 3.5 is 70. And 70.5 plus 3.5 is 74.5. So I would say that if I was going to draw a line anywhere around 75, it would probably be right in here. Yeah, we know from the empirical rule down here that the middle is what? 50. So this is 50%. And that's why you have to know the empirical rule. If you don't, you're going to be without a paddle. So there's 50% from the left all the way up to this point. Add those numbers up. And there's your empirical rule right there. All right, now, we know that half of this to 1 is 34. And you got to use interpolation. Interpolation is when you divide and divide and divide and divide until you get what you want. So 34 divided by 2 is equal to 17. So halfway between 0 and 1 is 0.5. You know that's 50 plus what? 17, which is 67%. So you know that's at 67. Well, what's halfway between 0.5 and 1? You know that's 0.75, but what's halfway between 17? What's half of 17? 8.5. So you can add 8.5 to 67, and what do you get? You get basically that number. And that's where you got it right there. So this is approximately, that magenta line represents, if you had to put a, hold on a second, I'll try to do it where y'all can see. Right here, that would be around 0.75 what? 7500. Now, is it exact? No. All you're doing in 7.1 as far as the normal curve is you're estimating where the areas are. That's all you're doing. 7.2, you actually get into the formulas, and we're going to get into that today. All right, so let's do another one. And this time, the mean is not going to be 0, and standard deviation is not going to be 1. But what do you got to do? You got to draw a picture. I think I'm going to have a heart condition.
A little itch real good. It's okay.
All I need is a doctor to say I have a heart condition, and then I won't have to teach anymore.
Come to my work, I'll give you because you're the
Okay, thank you. Make it look like a basketball. Okay. Now, I'm going to say that my mean, this is a IQ score, and the mean is equal to 100, and the standard deviation is equal to 25. So you're going to have to rewrite this right here. So you just need to mark through all of these. And you need to change this. What's the middle?
100.
And then add on the left and the right. Subtract on the left, add on the right. And then I want you to tell me what percentile is represented. I'm asking you for the opposite this time. Well, percentile. What? No, I'm not. I'm asking for the percent. What percent is at 150? I'm going to draw a little line right here. How do I know to draw that line there? Well, when you do your standard deviation, what's your first number? 125. What's your second number? 150. So I want to know what this area is, and I'll take my handy dandy straight line maker, and I'll draw you some lines. Now, you noticed I gave you an even number, didn't I? I didn't give you something in between, did I? Because you're relying on your empirical rule here. So all you got to do is take your empirical rule and add up what? Your percentages. Of course, if you don't know them, then you're SOL. So I'm going to pull in my handy dandy mental representation of the thing I was supposed to learn back in the first unit. And I put that under here because I'm mentally thinking at the same time. So 0.15, 2.35, 13.5, 34, 34, and what? 13.5. Add all those up. And that's your answer. So the area in this magenta is, somebody tell me what it is again? Oops. How did I do that? Hold on. There. 97.5, which is 0.9750. And that's what you're going to be doing in 7.1 and 7.2. Really? I'm trying to do something for y'all. There we go. 0.9750. And that's how you do 7.1. And how many questions will be on the test like that? Probably 3. You might have 2 uniforms. No, you'll just have 2 uniforms because you have to know how to do this part to do 7.2. You have to know how to be able to change that 0, 1, 2, 3 to 100, 125, 150, 175, minus or 75, 50, and 25. And you've been doing that since the first unit. So let's move to 7.2. Now, for those of you that walked in a half hour late or whatever the case may be, 7.2 is going to be going over these 3 things. And that's your z-score. And Oz plus mu. Of course, that's not written like Oz plus mu. That looks like Zo plus mu, but I change it to Oz plus mu. Those are the 2 formulas you're going to be using in this section, 7.2. And you're also going to be using these guys right here. Now, if you have these in your book, go ahead and get them out now. If you don't have them, then you're just going to have to get them at home and write good notes to see how we use them. Okay? They're in your book somewhere. Don't ask me where, but they're in your book. If you've got a laptop, then pull the laptop up, go to chapter contents, and I think under chapter contents you'll be tables and appendices. Pull up tables and go to A2, Alpha 2, and I'll pull that up. Okay? But you need it. You need something for your notes. So either you're going to have to draw a little bit, or you're going to have to pull it in your notes, whatever the case may be. All right. Sorry, what? Under chapter contents, go under appendices and tables. It'll say appendices and tables somewhere. It should. Yeah. And look for A2. Or just go to A2. And it'll look like this right here. It'll have negative z-scores on one side, and it'll have positive z-scores, 2 pages. Okay, now let me pull up a problem. I better go here. I guess I can go here. I think I got a problem in here somewhere. Yeah, here's one. All right, you don't have to write it word for word. Just write down the gist of it. And what's the 2 most important numbers in probability and statistics? Mean and standard deviation. If you're given the mean and standard deviation, the first thing that should pop in your head is what? Draw a picture. Now, is your mean 0 and standard deviation 1 or different? It's different, so you're going to have to change these guys. You're going to have to write a line through it. Because the mean is not 0, it's 0.1. So you're going to have to put 0.1 in the middle. And what's 10 cents plus 90 cents? That's $1, 1.0. And then $1 plus 90 cents is 1.9. And then $1.90 plus 90 cents is what? Yeah.
The mean is 0.9.
Mean is, oh, I'm sorry, I did it backwards. Sorry. Not reading. I read it backwards. Okay. The mean is 0.9. All right. What's 90 cents plus 10 cents? $1. And what's $1 plus 10 cents? $1.10. And what's $1.10 plus $1.20? 90 cents minus 10 cents is 80 cents. 80 cents minus 10 cents is 70 cents. And 70 cents minus 10 cents is 60 cents. So that takes care of all of this. If the machine is used 500 times, approximate how many times will it be expected to dispense 1 ounce or what?
More.
Or more. What is 1 ounce or more? It means anything what? Below 1 or anything above 1? So I'm going to take my handy dandy highlighter. And there's 1 ounce. I want to know what that probability is right there. I'm sorry, what? Yes, I want to find the area of the highlighted region. Now, there's 2 or 3 things that you've got to remember here. Hold on a second. I'm going to do the straight line in magenta because I want you to see. Okay? For one thing, and I'm going to put this in your text. You need to write this down. The table, the Z table, only gives quotation area to the left. The Z table only gives you this area over here, the area to the left of your mark. So therefore, any right-hand side will be 1 minus the what? 1 minus the left-hand side, which is the what? What is that called? Complement. So what I'm going to do is I'm going to take my handy dandy highlighter and we'll color it green. The table is only going to give us the left-hand side of your mark. So the table will only give us the green area. We don't want the green area. What does the question ask for? The green area or the yellow area? It asks for the left. It asks for the yellow area. Well, the yellow area is the right-hand side. And in order to get the right-hand side is equal to 1 minus what? The left-hand side. Because the area under the whole curve is equal to what? 1. That's where the 1 comes from. So, what we got to do? Well, first of all, we got to change this to z-score because we don't have it as a z-score. Z-score is a standard deviation, a mean of 0 and a standard deviation of 1. So we've got to use our handy-dandy formula. And our handy-dandy formula, I'm not going to pull it up because it's in that blue box, is z-score is equal to x minus the mean over standard deviation. All right, so what's our x? 1. So z is equal to 1 minus mean is what? 0.9 over 0.1. Now you don't need a calculator because you know how to do math. You know how to do money. What's a dollar minus 90 cents? And what's 10 cents over 10 cents? 1. Now, is this going to come out all the time? This 1 is equal to this 1? No, it will not. Now, it just happened to, this one, it happened to be a coincidence, but it's not always going to be that way. So, you got to look up a z-score of positive what? 1. So, you go to your handy-dandy z-score. Sorry. Where's my z-score? There it is. Now, is 1 a positive z-score or a negative z-score? Positive. So I take my handy-dandy straight line maker. I'm going to do it in aqua. And I'm going to underline. Oops, that's too big. Well, I could do, no, I'm not going to try that. Hold on a second. There we go. That is a straight line, right? Yeah. There. Go to 1.0 and highlight that line. And then I'm going to take another color and magenta. And 1.0 plus 0 is 1.01, right? So where do they intersect? At 0.8413. 0.8413 is your area. So you go back to your handy-dandy drawing and you type in 0.8413 is your green area. What'd I say? 0.8413? But that's fine and dandy, but that ain't giving us our answer because we want the yellow area. So to find the yellow area, you know that the area under the whole curve is 1. So the area of the yellow region is equal to 1 minus 0.8413. Now what's a dollar minus 84 cents? 16 cents, but you know it's going to be less than 16 cents because of the 1.3, so it's going to be 0.1587, right?
Yeah.
0.1587. So the area of the yellow region is 16%. 0.1587.
Can I just add that the empirical rule?
No,
16?
you cannot. That just come out to be, because most of the time this is not going to come out to be exactly your z-score.
Okay.
Sometimes it's going to come out to be 1.7. Okay. So let's do one. I'm gonna see if you can. I'm gonna see if y'all can think here. Okay. I'm gonna start another one, and I'm going to take my handy dandy picture. And I'm going to draw it bigger because and I'm going to say a mean, I'll be easy on you, of 100 and a standard deviation of 15. And I want you to tell me the area or the probability that a score is going to be between 80, and 112. That's not supposed to be 115, it's supposed to be 115. I mean, 15, sorry. Now, the first thing you got to do is draw a picture. So that means that your zeros and ones, they're going to be taken out. You got to start again. So take these out. And draw another picture. And then shade in what you're wanting, and then get the z-scores. If you try to just look at this and look at this, you'll stare at it all day long and never figure out what to do. You've got to draw a picture. And I know some of y'all are extra lazy, but if you don't draw a picture on these, you're probably going to fail the test. I take my handy dandy. That's going to be 100, 115, 130, and 145, and 85, 70, and 55. Now I'm going to take my handy dandy rectangle maker. And I'm going to make it magenta. I want to know the area between 80 and 112. Take my highlighter. I should have done a straight line, I'm sorry. I suck. There. So take my handy dandy highlighter. That's the area you want. Now, before you start this problem, let's say that you were going on a trip. And you were going to go from Anderson to Spartanburg. And let's say that you clocked to Greenville on your miles per hour, your odometer, and you know that it's 30 miles from Anderson to Greenville. And you know that from Anderson to Spartanburg is 145 miles. So if you wanted to find out how far it was from Greenville to Spartanburg, what would you do? So anytime you want to find something in the middle, what do? You subtract. Now, let's go back. What do you want to find? You're wanting to find this area in between. Well, what's the big area? Well, I'm going to take my handy dandy, something that'll stick out, red. and I'm going to highlight the big area in red. No, that's not big enough, Hubert. Hold on a second. There we go. Now the red area is at 112. Everybody agree with that? And I'm going to take my handy dandy blue marker and subtract the little area. And your little area is at what? Is at 80. So the red area minus the blue area is going to be the what? The green area. So all we have to do is take our z-score at 112, our area at z of 112, and subtract our area z of what? 80. Okay? So we got to find our z-score at 112. So z-score at 112 is going to be z at 112 is equal to 112 minus 100 over 15. And that's going to be 12 over 15, and you don't need a calculator to do that, because what? 3 will go into both of them. What? 4 over 5. I'm going to show you a trick I learned in the war here. Look here. Y'all watch this. How many times will 5 go into 10? 2 times 4 is 0.8. So the red area is 80%. Okay? Everybody agree with that? Well, yeah, because that first area right here is 84%. Didn't we say that's 84%? So the red area is 80%. So let's find our z at 80. No, that's not 80%. Our z at 80 is let's say these are IQ scores. This is 80%, the 80% score is equal to 80 minus 100 over 15, and that's equal to negative 20 over 15. Well, that's going to be what? 4 over what? 3? Negative 4 over 3, which is equal to negative 1.33. I'm sorry, that's 0.8. That's a z-score. I'm sorry. 0.8. Now, go to your handy-dandy tables. You got to find your area at 0.8. I got confused a while ago. Get your area at 0.8 in your z-score and your area at negative 1.33 and subtract them. So that's where I'm going now. I'm going back to my... There we go. So let me get rid of these guys. All right, what's our first one? 0.8. So I'm going to take my handy dandy straight line maker. 0.8. And 0.8 is 0.8 plus what? 0. What'd y'all get? 0.7881. Okay, write that down. 0.7881. And then we'll change colors. And we'll do green over here. What was my other number? Negative what? Okay, so that'd be $1.30. And then what's 1.33? $1.30 plus what? 3 cents. $1.30 plus 3 cents There you go.
All three. Oh, because it's 0.33. Okay.
So that's 0.0918. So write those two things down. I'm going to just use it right here. The first one was 0.7881 minus the small area, which is 0.0918. Now use your calculator.
0.3879.
No.
79
cent minus 9 cents is 70 cents. So it's going to be around 70 cents. I'm sorry, what?
69.63.
69.63. So our green area is 0.6963. All right, let's do a derby. I think I got one for you. No. All right, there's your question. Draw a picture. Give y'all a couple of minutes to draw a picture and see what you can come up with. Have a good afternoon at work.
Yeah. Right.
My vibrator's going off. Everybody through drawing a picture? All right, what goes in the middle? 72.3. And this is just like we've been doing since the first week of class, or the second week of class. And then what do we do on the right? Add 8.9. So somebody give me those three numbers. 81.2. 90.1. And what's the last one? 98.1. And somebody give me these three numbers. What?
Yeah. It's 99, sorry. 98.
Okay, I can't rely on y'all. Okay.
My bad. Yeah, I realized
Great.
that. That's right.
99.1.
What's just 99?
It's 99.
0.0. Okay, thanks for the misinformation.
You're welcome.
All right, now subtract. Give me those three numbers.
Not doing it.
Not doing it.
63.4.
What?
63.4.
And
54.5.
and
45.6.
okay, so we got our picture drawn. So we've got all this information gone. You don't need this anymore. How many students can blah, 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 82 and 90? So you take your handy dandy straight line maker and you draw between 82 and 90. So you're wanting this area right here. Now, to get that area, you've got to take the, I'm going to say green area, which is at 90.1. And you got to subtract the what? Oh, hallelujah, it's raining. I hope it rains all day. I could care less about the grass in my yard. It can die. My pastures. I'm feeding hay that I'm supposed to be feeding in the winter. Anyway. And I'm going to make sure, I'm going to take the, I'm going to color it, this will be the small area. Y'all get the point. So, the purple, the magenta area is going to be the green area minus the what? The aquamarine area.
Aquamarine.
Yes. Okay? But we can't do jack until we change 82 and 90 into what? Z-scores. So, take our handy dandy 90, change it to a Z-score. So, Z sub 90 is equal to 90 minus 72.3 divided by 8.9. Miss Nix, what do you get? Not going to do it.
No. I was subtracting the wrong number, so I'll need just amount, please.
All right. I'll go ahead and write the other one up. And then Z sub 82.
1.988.
1.98. Well, 1.99.
Yeah, sure.
Okay. Oh, please rain more. Z sub 82. How long has it been raining? Is equal to 82 minus 72.3 over 8.9. Somebody give me that number. 1 point what? So this point is 1.09, and this point is 1.99. So get your handy dandy table. And I'm going to take my black marker. 1.99 is 1.9 plus 9 cents, right? So 1.9 plus 9 cents. All right, write that down. That's 0.9767. 0.9767. And what's the other one? 1.09? Well, that's 1.0 plus 9 cents is 0.8621. 0.8621. So, the blue area, or the area that we said is aquamarine, what was the aquamarine point? What? 86 what? 0.8621. And the green area I'll put right here is what? 97 what?
677.
That's the green area. So you need to make a note that this is the green area and point it to the big area, this green area. So 0.9767, which is your big area, minus 0.86. Thank you. Such a wife. 0.8621. And 97 cents minus 86 cents is going to be 13 cents, but it's going to be 12 cents. 0.1246.
0.1146.
0.1146. I'm sorry. 1146. And that is what area? Tell me the color that that represents.
Magenta.
The magenta or purple, whatever you call it right there. I'm sorry, what? 11.46. Whatever they asking for. How many students? 12 or 11? Be 11. 11 students. How many students in the class can be expected to receive a score between 82 and 90? 11. All right, now get your calculators out. You're going to love this. Take your handy dandy calculator. And all you got to know is z-scores. Take second, VARS, normal CDF, number 2, and give me the 2 z-scores.
0.9767.
I'm sorry, it was 1 point something. 1.09?
No, 0.9767.
That's not a z-score. That's the area.
1.99.
1.09, right?
And 1.9.
1.09, watch this, comma, 1.99, close parentheses, enter. There you go.
I can have negative.
Mine was a screen reflect over.
You have to type it in. Yeah, some of them are a little bit more advanced. Normal CDF, 1.09, comma, 1.99.
I think it's because I put 1.99, comma, 1.09. They gave me negative.
It shouldn't. Yeah, don't put it in backwards. Read from left to right. Which one's the lowest? 1.09.
I got you.
Now, what if I wanted to find an area and they gave me or z-score, or they gave me an area and I want to find the z-score? Then you hit second, bars, inverse norm. Somebody give me a percent. 0.2000. Enter. Negative z-score, negative z-score, negative 0.84. So if you wanted to find a z-score, and I'll give you an example of this in just a second, I'll do a problem and give you an example. You got to find a z-score. Given an area, there it is, inverse norm. So write those two things down in your notes for the calculator. And here's the problem.
The z-score with an area is the INV norm.
Given an area, find the z-score. Normal CDF is given a z-score, find the area. They're opposites of each other. All right, here's a problem. Let me get a new page. Here we go. A recent math test was given with a mean of 72 and a standard deviation of 5. What score represents the 80th percentile? Now, what are you given? What are you given? You're given the area. The area is equal to 0.8000. So you need to say, given your area is 0.8000. So they're giving you the area, so that means you got to find a what? A z-score. Or you can draw a picture and draw it out.
Or I can just take the calculator and do that thing you just said.
But you still need a picture to understand what you're doing. Both. So draw a picture. That'd be 72, 77, 82. Y'all help me out because I can't add too well. And 87. 72 minus 5 is what? 67. 62. And 57. And they want to know what score represents the 80th percentile. So this is what they're giving you. Take your handy dandy highlighter. 80th percentile. Well, we said this was 84, right? So 80th will be right in here. So they gave us the area is equal to 8,000. So you got to find a what? A z-score, but z-score is not going to help because they want to know what score represents the 80th percentile. So after you get your z-score, you got to turn it into a test score. And when you have to turn it into a test score, you're going to use Oz plus mu. Okay, so the first thing you got to find is what? Your z-score. And then once you get your z-score, it's just plugging and chugging. So how do you find your z-score in the notes? I meant the table. Do you look up a z-score or do you look up an area? Area. What is area? 4 place values, right? So find the 4 place values that is close to 0.8000. .8000. Where is it?
0.781.
Well, here it is, right here. Y'all look right here. $80 is between $80.23 and $79.95. Which one's closest? $79.95, Hubert. That's right, all of the class. You should know that.
Well, how did you know to go between 4 and 5? 0.04 and 0.05.
What do you mean?
What number are you using to get there?
80%. 0.8000. Remember, when you got 4 digits, what is that?
Area.
And the area is these areas. There's only one place that you're going to find 0.8000. So you look at your numbers. This is 50s, 60s, 70s, 80s, 90s. There's only one place. And it's closer to what? 79.95. So you're going to use this column. So what is your z-score? 0.8 what? 0.8 plus 4 cents is what? 0.84. So your z-score is 0.84. Well, let's look back. Is that right?
Yes.
Look, common sense.
0.8414.
Look, what am I between? 0 and what? I'm closer to 1, so 0.84 would make sense. So our z-score for 80% is 0.84. So what am I going to do with that z-score? I'm going to plug it in, Hubert. That's right, class. Standard deviation is what? 5. And 72. All right, somebody take 0.84 times 5 and add it to 72. Tell me what you get. I bet you it'll be between 72 and 77. How do I know that? Because I drew a picture. It's going to be between 72 and 77. I say 75. What does it come out to be? I'm sorry, what? 76.2, and that's the score that represents what of the class? There you go. So 76.2 is the score for 80% of the class. So if you made a 77, what does that tell you? You're in the top 20%, Hubert. That's right, class. If you made a 64, live in the ditch. You're in the bottom 80%. And that's how you use z-scores and areas. Now, I'm just throwing it to you, and I'm not going, no, I know Thursday you're going to have a bunch of questions. And we're going to be going over some more of these. I'll give you 5 or 10 more problems to do like this. All right? Because this is very important. You should know how to do this stuff. I don't even know what time it is. Somebody tell me what time it is. I think that's good enough for government work.